Okay, so we start this new recording by considering now the MCQ, let's say the MCQ number 9. Okay, so here the function we want to integrate is the following. Okay, and I just want to remind that let me clean the board first. I just want to remind that the integral, let's say not the integral, if I have the function f equal to square root of x squared minus 1, then f prime, as the formula is that if I have root of f, the derivative will be f prime divided by 2 root of f. So the derivative here will be 2x over 2 root of x squared plus 1. And thus it will be x over root of x squared, I mean x squared minus 1. Okay, thus if I integrate x over square root of x squared minus 1 in dx, I will get square root of x squared minus 1. So this is important to know. Now, as you should probably know, I say that you should not miss this kind of question at the exam, because if one doesn't know how to integrate, he can just derive this until he find which one match with the given function. Okay, but in this we are going to the integration will be a bit tricky, but we should reach the, let's say, the answer we need. Okay, nice. So let's move on. To move on, let's continue by I write the integral we want to solve is the integral of x squared minus 1 over x in dx. This integral is actually equal to, we can multiply and divide by it. So I mean, like this, we can write it like this. Then you will understand why we are doing like this. It becomes the integral of x squared minus 1 over x multiplied by x squared minus 1 in dx. Now we can split, that become the integral of x squared over x root of x minus 1 in dx minus the integral of let's say minus the integral of yes, 1 over x square root of x squared minus 1 in dx. This one, x, yes, thanks, good. So nice. This simplify to x over square root of this is square root. Any question you said? Okay, yes. So this becomes square root of yes, x squared minus 1 in dx minus this integral here minus in fact I would like to write it like this instead. I want to write it like let's say 1 over square root of x squared minus 1 all over x, the integral in dx. It's the same, right? Because it's simply 1 over square root. It is the same, because if you do this computation, you get back the same function. So now you see that I can write it like the integral of x over square root of x squared minus 1 in dx, because I know how much is this integral because we saw it up. Yes or not? That is, so I am just trying to work on this one, to work out this one, then the second, this one. So but another here at this step, I ask you to multiply up and down by x squared, by x I mean. So it is minus the integral of, so I write the same thing, 1 over square root of x squared minus 1 over x. Now look, I am going to multiply here by x and up by x. It's the same thing, right? Now what come out? It come out that it gives me the integral of x over square root of x squared minus 1 in dx minus the integral of up. I will have x over square root of x squared minus 1 over x squared in dx. Some last steps. Integral of x over square root of x squared minus 1 in dx minus, now this is the integral of x over square root of x squared minus 1 over this x squared. Let me this x squared, I can write it technically means that I can write it like this. This x squared can become like, I can write it like 1 plus square root of x squared minus 1 all square. Let me write it better. It didn't come clear. If you perform all the computation, it should be the same. I mean, you can write it like 1 minus square root of x squared minus 1 all square. Is that clear? If you square this, no, it is 1 plus, not 1 minus. Okay, you square this, the 1 and the 1 will cancel, and you remember only with square. Now look at what all the stuff we are right now, because this integral here, we know it is square root of x squared minus 1, right? But this, look, if this is if you say that this is your f prime and this is your f, the derivative of square root of x squared minus 1 is this. We set it up, right? So this is nothing more than, so this integral here is the integral of f prime over 1 plus f squared, right? So it is just r tan of f, that is equal to r tan of f. So finally this one, this piece give you square root of s squared minus 1 minus the other piece that will give you r tan of f, which is square root of x squared minus 1 plus c. Okay, it was long, but we solve it. So the answer is c, because minus c is here they are taking c to be equal minus 1. Remember that c means plus any constant, right? In this example they took c to be minus 2, so because you wanted a primitive, not all the primitives. Good. Can we no, the answer is no, not e, excuse me. This says that no, excuse me, a primitive of this function is no, it is b, it is c, it is this one, because here you have cubic root, root of x cubed, but it should be x squared. Okay, it is c, so the answer is 9c. Doubts? Okay. Then, given the function f of x equal to 1 over x minus 1 over x minus 2, which one of the following is false? Okay, so let me clean the bar. So you have the function f of x equal to 1 over x minus 1 over x minus 2. We are finding for the one which is false. Okay, so this says that the integral is equal to this. This is true. Yes or not? This is the integral of f prime over f that we know to be equal to the logarithm of absolute of f. So if I integrate f of x, it will be like doing the integral of 1 over x in dx plus the integral of 1 over x minus 2 in dx. This is f prime over f, so it will be the log of absolute value of x plus this is also f prime over f, so it will be the log of absolute value of x minus 2 plus c. Okay, so just to make sure that this is very clear, so look, if x is greater than 0, if we take any x greater than 0, so let's say that this is these are all the primitives. If we take x greater than 0, we can cancel the absolute value, so it will become the logarithm of x plus the logarithm of x minus 2. But the logarithm of a plus the, I remind this property of the logarithm, I remind that, but okay, when you have log of a plus log of b, it is the log of ab, yes or not? So this can be written like log of if you want x multiplied by x minus 2, but this hold only for x greater than 0. But if you want to write it in general, you should use the absolute value. So if you want to write it for all x, you should say that it's the logarithm of the absolute value of x times absolute value of x minus 2, right? Or in general, we are using this formula of the logarithm. The log of a plus the log of ab is the log of a times b. So let's go and see among the answer we are looking for, searching for the one that is false. So the first one, the function was minus, okay? So here there is a minus, not a plus. And so is here there is a minus. Let me excuse me. So I repeat here the formula. The logarithm of a plus the logarithm of b is the logarithm of a times b. Is that clear? The logarithm of a minus the logarithm of b is the logarithm of a over b, right? In fact, n times the logarithm of a is the logarithm of a to power n. Good. So this means what? That the we got that the primitives for this function was f of x equal to the logarithm of absolute value of x minus the logarithm of absolute value of x minus 2. This for all x belonging to let's say that this is for all x not belonging to R, but let's write it like this for the sake of simplicity, okay? But now so a is correct, right? Now the primitive of f of x that is 0 in x equal 1 is f of x equal to, let's see if so we are saying that this primitive when x is 1, so if we put x to be 1, the function should give 0. First of all, is this function a primitive? If it's a, let's check this function, this f of x that they gave us, is it a primitive? The answer is yes, because if you consider that, if you consider what you see here, if x is greater than 0, if you take, as we are working in 1, it means that x is greater than 0, right? So if x is greater than 0, we can write that f of x, big F of these primitives here will become the logarithm of x, because I don't need the absolute value if x is positive, right? Minus the logarithm of x minus 2. So in fact, using this formula, using the fact that the logarithm of a minus the logarithm of b is the logarithm of a over b, this will become the logarithm of x over x minus 2. Now I have to check, is f of 1 equal to 0? In fact, if I put 1, I will get the logarithm of 1 over 1 minus 2, right? That gives me the logarithm of minus 1. That does not exist, right? It means that here this is false. Ah no, it was 2 minus x. No, it means that C is correct, but B is correct, but C is false. Yes or not? Doubts? Yes. In fact, this function is not even this one here. It's probably not even a primitive, because it should be x over 2 x minus 2, not x over 2 minus x. Okay? No. This is we want the excuse me. We wanted the one which is false. The primitive of f that is 0 in x equal 1 is probably a primitive here, but is it a primitive at all? Is it this function? Is it a primitive? In fact, let me check it. How is it a primitive? Yes, because it is. Look, in fact, it's a primitive because why is it? So we are asking ourselves if the function log of x over 2 minus x, is it a primitive? Because we are expecting the primitive to be in the form log of x over x minus 2, right? But why this function is a primitive? Look, that this function can be written like the logarithm of so it is no, but just for the moment. But it's the primitive of f of x that is 0 in x equal 1 is the log of x over 2 minus x. Why is it so? Why is it so? Okay. Can you hear me? Okay. So we are trying to understand why b is a primitive. Okay, f of x equal to x over 2 minus x. What is wrong with this? Okay, by the way, let's check if the simplest way to check it, because probably there should be a way to write it in this form, but let's check. I prefer maybe to try to check how if the derivative of the b, if the derivative of this gives this function, right? Probably if you check what if you try to do the derivative, try to do the derivative of x over 2 minus x and check, it should give you this form, this function. Okay, remember that the log of f, the derivative is just f prime over f. Okay, yeah, yes, b is correct, because f of this one c is false for the reason that if you put f1 here, is that clear, you will get logarithm of -1, which doesn't exist. Doubts? Okay. Questions? In fact, yes. You don't even need to put the. In fact, the primitives are f of x equal to. Let's say we saw that it was log of absolute value of x minus log of absolute value of x minus 2, right? So this will be actually log of absolute value of x over absolute value of x minus 2. Okay, when x tends to 1, this stuff is still negative. If you put 1, it will be minus 1, right? When the absolute value is negative, to eliminate the absolute value, you should write, instead of writing x minus 2, it will become 2 minus x. That's why the primitive when x tends to 1 is logarithm of, when I cancel the absolute, here x is 1, so when x tends to 1, x is positive, so I can eliminate the absolute value, right? But down, to eliminate the absolute value, instead of writing x minus 2, I will write 2 minus to make it positive. That's why. Is that clear now? Okay, good. Nice. So okay, so the one which is false is C, right? It's B. We say no, C, excuse me. So the answer is 10C. Okay, nice. We also stop here for this recording and continue in the next section.